In today's lesson, we're going to graph and write equations of parabolas. Now, we're going to first dissect the different parts of a parabola. And I'm going to show you the different parts of a parabola in this upper left one, the one that we've known to use, how to use before, and we're going to put a slightly different light on it, a different way to look at parabolas, and then we'll look at the different ways that we can graph these parabolas. So first I want to point out a parabola we know has a vertex, okay, and this is nothing new. It's either the lowest, the minimum, or the highest point, the maximum of that parabola. The another important point of a parabola is a thing called the focus, okay? And simply what the focus is a point inside the parabola, but it's a special point. It's not any point. In this case, the focus is located at 0p, where p is how many units up on the x-axis we go in this case. And I want to point out that all the parabolas we're going to be doing here are going to have a vertex at the origin, 0, 0. But there's also another important feature. It's a line called the directrix. And the directrix is y equals negative p. Now, I want to point out that the distance from the focus to the vertex is congruent to the distance from the vertex to the perpendicular point on the directrix. So these distances are the same, and we can see the directrix is is y equals negative p, telling us that it's a horizontal line. In this case, p units down. An interesting thing about this, the focus, and a very useful point, is that if you take any point on the parabola, any point whatsoever, and then you were to draw a line from that point to the focus, and then from that point to a perpendicular point on the vertex, in this case, even though my graph doesn't look it, my graph's a little distorted, it's actually, they're going to be congruent. The distances from here to the focus is congruent from the distance from that same point perpendicular to the vertex, and it's always going to be the case. So every single point along here on either side is going to be like that, and that's going to be an important property that we'll use in certain type of problems. We do have an equation here, slightly different than what we're used to seeing. I'm going to go into these a little bit more detail, but for this one, it's x squared equals 4py is equal to, or such that p is greater than 0. Now, we can reflect it down where the focus is now below, but the directrix is above the parabola. Everything else is the same, but notice how the p value here is still positive because the p value here is a distance, okay? It's not an actual coordinate, it's a distance. Now this is located at point 0, negative p, but it's actually, when we look at p, it's actually a distance. When we see this in our equation, that corresponds to the p value here in this equation. But an interesting thing is that we can actually put the parabola on its side, where, see, the parabola always goes around the focus. Okay, so the focus is still inside, but this time the parabola is opening to the right. and the directrix is to the left of it, and here it's opening to the left. So we want to be able to describe, does a parabola open up or down, which would be a vertical opening, up or down, or does it open right or left? Okay, and notice that those equations are slightly different because it's equal to y squared for the horizontal ones. Okay, so these are four things you need to know for these types of parabolas. And that is, you need to know what the equation is. So this one is for your vertical, the top row is for your vertical parabolas, and this is for your horizontal ones. So the vertical ones are the ones that open up and down, and the horizontal. So the equation for the verticals, x squared equals 4py. The focus is located at 0p because it's on the y-axis, so it's not moving left or right, so 0p. Again, that's a distance. The directrix is at y equals negative p, so on the other side of the vertex, and the axis of symmetry is going to be vertical. The axis of symmetry is what's cut in half, and it's relocated at x0. And then, so basically with the horizontal, a lot of things, everything's flipped. So for horizontal, it's going to be y squared equals 4px. That's the equation. And the focus is going to be located at p0, so that's going to be the inverse, it's flipped. And the directrix is instead going to be at x equals negative p, so remember that's a vertical line, and then the horizontal, or the axis of symmetry is going to be horizontal right along the y-axis. So these are four things that you will need to show and declare on your graphs. So let's go ahead and graph one. Let's do an example. And we're going to identify the focus, directrix, and axis of symmetry of y squared equals 20x. Then graph it. The first thing you want to do is determine if it's a vertical or horizontal parabola. And since this is y squared equals, it's going to be horizontal. So we know that the equation for that is y squared equals 4px. Okay, so now that we have that, the first thing I want to do is find the focus. So we're going to write focus here, and I'm going to underline that, and I'm going to do my work for finding the focus. Since the focus is equal to p, all right, we want to find p here, but right here we have 20, okay, and then x. Well, 20 is equal to 4p according to our little equation here. So 4p equals 20, so therefore p has to equal 5. So therefore, this being a horizontal parabola, the focus is going to be on the x-axis. So it's going to be at 5, 0. Okay, because when we solve it here, we can see that the sign is positive. All right, so in our formulas it declares it a distance, but when we actually work it out, we can see if it's going to be positive or negative. And I'm going to actually box that in because this is going to be one part of the features of the parabola we need to declare when we graph it. So then the next thing I want to find is the directrix. So the directrix is going to be on the opposite side. It's going to be in this case, a horizontal line. So it's going to be, it's going to be a vertical line because it's going to be on the other side of the vertex. So it's going to be x equals And so that's going to be negative p. So in this case, it's x equals negative 5. So that's going to be the equation of our directrix. Okay, so now we need to identify the axis of symmetry. And the axis of symmetry is just going to be the x-axis. So that's going to be y equals 0. And I'll box that in. Okay, I'm not going to make you declare the vertex since all of these are located at the origin. So I can actually tell a lot from the about the parabola just given this information. So as I plot this, I know that the focus 1, 2, 3, 4, 5 is located here, and since it's to the right of where the vertex is, which is at the origin, this parabola is going to open up to the right. I'm also going to sketch in the directrix, just so we know where that is. So 1, 2, 3, 4, 5 in the other direction. So that's going to look like that. More. And then my axis of symmetry is going to be right here. Now later on we'll shift these, but you know, I'm having you graph them for now so that we're developing good habits for when we do our transformations, but that's going to be much later. So now that I have that, I can go ahead and graph my parabola like so. So the parabola opens to the right, going around the focus, goes through the vertex, opens away from the directrix. And so there you have your parabola. Okay, in this next example, we're going to go the other way. We're going to write the equation of the parabola shown. So we need to identify the key features of this parabola. Now, this graph might be a little bit confusing. My y-axis is right here. This labels what the y is, and here's my x-axis. The line that runs this way is x equals 3, and that's going to be my directrix. Okay, so anyway, first I want to know which equation am I using. Since this is opening to the left, then it's going to be a horizontal, so we'll use that equation. Y squared equals 4p times x, and we want to be able to identify, okay, well, what is my value of p here? And so p here is located right here at -3, 0. So therefore p is going to be -3, and I can verify that because the directrix is going to be the opposite value, what x equals, which is +3. So all I have to do is substitute p in, so y squared equals 4 times -3x, and then y squared equals -12x. And then that's going to be my equation for that parabola. So that's it. That's how you graph and write equations of parabolas.